Okay, worksheet number 5, question 6. A tramper came across a dark hole in the ground. She dropped a stone down the hole and heard it splash into the water at the bottom of the hole exactly 3 seconds later. How deep was the hole? I don't recommend you do this. There could be a hermit or someone living at the bottom of a hole, so just because you come across a hole in the ground while you're out tramping, don't throw stuff into it. However, let's have a look at this. Let's do our guess. What are we given? We're given that she was holding the stone and let it go, so the initial velocity has got to be 0. We'll be given that the acceleration downwards is 10 meters per second squared. So we're going to say distances, directions down are going to be positive. This will be the positive direction. So distances this way will be positive, velocities this way will be positive, and acceleration this way will be positive. And acceleration due to gravity is going to be about 10 meters per second squared. And we're given that it took 3 seconds to hit the water and splash. What are our unknowns? Our unknown is we want to know how deep it was. What's an equation which ties those together? Initial velocity, acceleration, time, and distance. How's this for an equation? Distance equals initial velocity times time plus a half at squared. Substitute. Distance we don't know. Initial velocity 0 times time plus a half times acceleration 10 times time squared 3 squared, and we have distance is equal to 45 meters. And again, make sure you've got your units in there, otherwise you've only got it half right and you lose. 6b. Calculate the depth of a hole for which the stone drop would take 6 seconds. So now we've got our guess again. We're told the time is going to be 6 seconds. Again, our tramper drops it, so just as it's dropped, the initial velocity is 0, so initial velocity vi is equal to 0. The acceleration 10 meters per second squared. What is it we don't know? We don't know the depth, we don't know the distance, equals we don't know. What is an equation which ties these 4 things together? It's the same as that one up there. D is equal to v initial times time plus a half at squared. D is equal to 0 times 6 plus a half times 10 times 6 squared, and the distance is equal to 180 units meters. 6c. Note that after 3 seconds it's fallen 45 meters. After 6 seconds it's fallen 180 meters. It's fallen for double the time, but it's fallen 4 times the distance. We need to explain why this answer is so much greater than that when the time's only doubled. Well, let's have a look at our equation. D is equal to Vt plus a half At squared. Let's look at this equation. What happens when we double the time? This is squared. The distance is proportional to the square of the time. So if we double the time, 2 times 2 is 4, the distance is 4 times as great. If we treble the distance, 3 times 3 is 9, the distance would be 9 times. So the answer is quite simply the distance covered is related to the square of the time. So when we double the distance, when we double the time, the distance increases by a factor of 4.